right. So for our warm up, natural log derivatives. Can I move the 4 out front in this scenario? Why not? It's only on the x. It is not on the 5. Would you agree? So when I take the derivative, I am going to take the derivative of the outer function, natural log, which is 1 over 5x to the 4th. And then I'm going to multiply that by the derivative of the inner function. What is the derivative of the inner function? 20x cubed. And if I can reduce, I'm going to reduce. And if I can reduce, I'm going to reduce. And what I end up with is 4 over x. Is that what we got? How many of you are starting by just going 5x to the 4th and then the derivative of the inner function goes on top? Perfect. That's what I was hoping. Okay. You don't have to. This is how we would have done it with the other ones. That's why I showed it here. But in the video, I was like, it's going to always end up being the derivative on top, right? Derivative of the inner function. How many of you got that one right? Okay. Oh, goody. Let's give us a really complicated one. That's the best thing ever. Thank you, Mrs. Burleson. I'm super excited. Is this one really any more difficult than the other ones we have done? Or that more difficult than the first one? What do I need to do first? Use properties of logs to write it so I don't have this quotient rule or product rule or power rule. So my first thing, don't say y prime equals. We are still dealing with y here. So is there anyone in here that can do all of them in one step? Do all of the log properties in one step? You're more than welcome to do that. I'm going to do them one at a time so I don't lose anybody. Okay. So the 2 comes out front. Right? And then when I have a quotient inside the log, that means that I had subtraction of the exponents. You can either write the 2 outside that entire difference, or you can put the 2 on each term. Doesn't matter. Now can I find the derivative? Can I do any more? I can do one more. 4 times the natural log of x minus the natural log of 2x to the 5th minus 3. So now when I take the derivative, y prime is going to equal 2 times. What is the derivative of 4 times the natural log of x? 4 over x minus what is the derivative of the natural log of 2x to the 5th minus 3? So my 2x to the 5th minus 3 goes in the denominator. Are you guys doing it this way? Put it there and then put the derivative on top. That's the way my brain works. So I'm going to get 10x to the 4th. Is that correct? Could I do work to simplify this? Actually, I would argue that that's not necessarily simplified, right? Do I need to do any more work to combine these or anything like that? Is that the derivative? That's the derivative. How many of you got that one right? Logarithmic differentiation. I like, because that process is pretty straightforward. Do you agree? Any questions? Yes.
Are you gonna deduct points if we don't simplify down to 4/x on like in class?
Yeah. Yes. No, you don't have to. You can if you want to, but you don't have to. Yeah. If you distributed the 2, you would have 8 over x minus 20x to the 4th over 2x to the 5th minus 3. I would hope that you have enough confidence in me as your teacher to recognize that this answer and this answer are equivalent. Yes.
If we did that, it was simplified it wrong.
That's a bad decision because you now had the correct answer on your paper and you lost points. And that's the way they do it on the AP exam also. So that would be my argument for stopping here. Because if you did that, nobody else has ever had a brain fart calculation on a test, right? If you did that and you got the wrong answer here, like maybe 8 over x minus 10x to the 4th over whatever, because you forgot to distribute to both, no one's ever made that mistake on a test, not ever a test that I've graded, correct? So you now have the wrong answer. So, and on the AP exam, they do not require you to do any more after you've taken the derivative. They would not even, I don't think they would not even require you to reduce like x cubed and x to the 4th and that stuff that Kenny just asked. I will because we have more time and it's not as high stakes. But on the AP exam, they want to see, can you take the derivative, not can you manipulate it afterwards. The only place you would need to manipulate it afterwards is if it's a multiple choice and the answer you got isn't there. Then you'd have to see which one matches from a manipulation. Any other questions?